All right, we're ready. Thank you for coming. This session is going to be about HTTP2. The protocol HTTP2 is an evolution of the HTTP 1.1 protocol. It's now 2 years old, and it has a lot of benefits. We'll see them all during the presentation. So let's start. My name is Simone Bordet. I work for an American company called WebTide that provides services and support for the Jetty open source project, the server container. So if you use Jetty and you need support for that, configuration, migration, etc., that's what we do. And through our client, we basically fund the open source project. But let's go into HTTP2, which is more interesting. So the question here is why? Why there was a need to go to HTTP2 and change the version that has worked for us for the past 20 years? Well, this is the reason. This one is the web 20 years ago. This one was the W3C homepage in 1996. 1996 was also the year that HTTP 1.1 was actually specified. The IETF published the HTTP 1.1 specification in 1996. Now, this page is one HTML page for 600 bytes. It didn't have any image, no CSS at all. This was all browser stuff. And so this was the web 20 years ago. And the protocol that was designed 20 years ago was designed to serve this kind of pages. Fast forward to today, and this is the web of today. This page is from the CNN about Top Chefs. This page is actually made of 215 HTTP requests to different domains. Most of them will be to the CNN.com domain. And actually, this page weighs 9 megabytes. It is 200 times more number of requests just to make up the page. And it is like a gazillion times more data that you have to download in order to get this page right. So what happened? Well, the fact is that the web literally exploded during these 20 years. HTTP 1.1 is a very old protocol. It is, for today's web, it is extremely inefficient. It doesn't have any multiplexing, it doesn't have resource correlation, and we will see during the presentation what these two terms mean and why they're so important. Web developers are now hacking around HTTP 1.1 protocol limitations. So, for example, things like domain sharding or resource inlining or image spriting. So how many of you, for example, have heard about domain sharding? A few, okay. Who's using image spriting here? Okay, a few as well. So these are considered best practices now, but they're really not. They're just hacks around a very inefficient protocol. It's a protocol that it was probably one of the most successful high-level protocols over the history of information technology here. But still, it's a protocol that has been designed 20 years ago. And we know what does it mean for our field to use stuff that is 20 years old, right? It's not even prehistory. It's like it's dinosaurs, right? So we don't want to use a protocol that is this old to run today's web. Also because it's not only about technical things, it is also about human web interaction, how the humans actually interact with the web. So we are the consumers of the web, and because of this, we want this experience to be really fast and satisfying for us. So if the website is slow, and just as an example, that CNN page that I showed you before completes the download of all the resources in 28 seconds, okay? So if we have to wait this much to actually read the content that we actually need, that's not good. So we want the web to be super fast. So much so that, for example, things start to change really fast and very importantly, like for example, Nordstrom is a very big e-commerce site online for North America, especially. They sell clothes online mostly. And so they switched their strategy from optimizing for IT cost, meaning we buy less hardware or we optimize the hardware that we buy, into that's not important anymore. The thing that we really care now is how fast we can deliver content to our user. It doesn't really matter how much hardware I need to buy. That's not a problem anymore. What I want is speed. And there is a very good reason for that, because speed is a feature, it gives you better Google ranking, but not only that, it is a business issue. Faster website mean more money. These are 5 studies that have been conducted in the past that show a direct relationship between how fast and how good is the interaction with a website and how much money do you make. So for example, Shopzilla, another e-commerce website, they reduced the landing page from 6 seconds to 1.2. They made 12% more revenue, 12%, and 25% more page views, just by optimizing the website. So if you ask anyone, okay, your goal for the next year will be to increase the revenue by 12%. That's, not easy to do, but you can do it technically. Just make the website faster. Amazon.com, this is pretty amazing. They have linked the fact that every time a page shows 100 milliseconds faster, they make 1% more revenue. So just to give you an idea, 100 milliseconds is a very short time. It is about at the edge of what the human brain can actually detect. When we close our eyes, that's 300, 400 milliseconds. So 100 milliseconds is still enough for the brain to feel that the website is faster. Our brain computes that and says, oh, it's faster, I want to stay on the website more, and I want to buy more stuff on this website because it's really responsive and I enjoy staying here. Another one is Mozilla.com. They shaved off 2.2 seconds from the landing page of Mozilla.org. That turned out to be 60 more million downloads of the Firefox browser per year. So again, if you set a goal at the beginning of the year and say, hey, you have to make things in a way that we have 60 millions more downloads of the browser, how do you do that? Well, that's kind of easy. Just make the website faster. So, point being that HTTP2 has been designed 2 years ago to cope with the modern needs of today's web. And it has been designed from the ground up to actually be faster, better, and with a lot of future possibilities and room for improvement for the future, so that HTTP 1.1 is now relegated to the dinosaur era. We shouldn't use that anymore, all right? So let's take a quick look at the main features of the HTTP 2 protocol, and then we'll discuss them. So the first thing is that finally HTTP 2 is not anymore a textual protocol, but now it is a binary protocol. This is not much for the end user, but for implementers like us, Jerry was one of the first to actually implement the HTTP 2 protocol. It is so much better to implement because it is much more efficient to parse and generate. This is really, really important because it allows implementation to be really efficient and use less resources on servers. So the way it works is based on frames. So every time a browser wants to send a request to a server, it packs the information, the request method, the URI, the HTTP headers, it packs them into a frame called headers frame and sends it to the server. If it is a post upload, then it packs the content of the post into a different frame called a data frame, okay? And then sends them to the server. And the server replies with another headers frame, but this time this header frame contains the response headers. and the status code and stuff like that. And of course, the content that is related to the resource that is being requested. This one is probably the most important feature for HTTP2. HTTP 1.1 works in this way. You open a TCP connection, then you send a single request onto this TCP connection, and then you have to wait for the response to come back. You cannot use that connection anymore. Once the request has been sent, that connection is gone. If you want to send another request, you have to open another TCP connection, send the request on the second connection, and wait for that guy to return. So now browsers open at most 6 connections to a single domain, okay? What does it mean? It means that if you have to download or make 215 requests to render your page, how does it work? Well, in HTTP 1.1, it works in this way. You open 6 connections, then you send 6 requests, they travel the ocean until America, where the server is based. They come back, then you send another 6, they travel the ocean and back, another 6, and so forth, right? By the time you arrive at 215, well, 28 seconds have passed, right? So it's not really efficient. Multiplexing solves this problem because this is how it works. The blue pipe here is the TCP connection. But in HTTP2, instead of sending just one request at a time, you can send multiple ones on the same TCP connection, okay? And, the first, these green pipes are called streams in HTTP2 parlance. And, this one was the first one that was opened. Then we opened this one, and then we opened this one. However, the good thing is that we don't have to wait for this guy to come back. Maybe the processing of this last request that we sent was really fast on the server. So maybe it gets responded first. But the client is able to reconcile these pipes, and so it knows that the responses can come back out of order with respect to the time we sent them. And so, but because they have a unique identifier, the browser and the client can reconcile this, the responses. And so, responses can come back out of order. Now, the default configuration for a browser is to be able to send 1,000 of these requests concurrently. So when you have 215 to send, well, that's not a problem. I can just open 200 streams, send all the requests together, and then let the server do its job. Big plus. Another thing that HTTP2 does is header compression. So if you're familiar with the HTTP protocol, there are constants that are typically sent over and over as headers. For example, cookies. They're constant. Once you get them from the server, every single request has a very long string that gets sent over for every single request. Same goes with the user agent string. It's a very long string that says what browser it is, what operating system, how big is your screen, and stuff like that. But it's a constant, okay? And every time you make a request to any domain, you're sending that constant. So what HTTP2 can do is compressing these headers and say, okay, I'm going to compress this information for the first request. So typical HTTP 1.1 request is 400 bytes, like a small one without cookies and stuff. But in HTTP2, the first request is already 250. It's already less. But all the next requests can go back down to 10 bytes, only 10 bytes. Why is that? Well, because the second request can say, hey, do you remember what I sent you before? So rather than sending the whole string again, what it sends is just a single byte that points back and say, hey, this is, remember the first one that I sent you? This is a pointer to that particular string, so I don't need to repeat the string anymore. I just use a pointer to that string, all right? So basically, from the second request on, I'm just sending pointers, and the requests are really, really small. The last big feature of HTTP2 is called HTTP2 push. Let me explain with a diagram how it works. So this is HTTP 1.1, typical interaction to render a web page. We make the request for index.html, okay? The HTML comes back, arrives in the browser starts to parsing it, okay? While it's parsing it, it discovers, hey, I need a JavaScript and a CSS to be downloaded, okay? Well, these are two resources. I can open two connections and send them in parallel. Those resources come back. The parser needs to parse them again, and then it discovers that the CSS contains a background image. And so it has to make another round trip to get the image. So in order to render the simple page, we need 3 round trips. Again, if you are in Europe and talking to a European server, that's fine. The server is in the United States, it's okay, it's 100, 150 milliseconds. If you are in Australia, the minimum latency to a server, like everywhere in the world, is 200, 250 milliseconds. So this page is already about 1 second. A super simple page, but it's already 1 second. All the time has actually been spent by TCP packets traveling the ocean. It's not really computation stuff. Here is, serving static files and stuff like that. So it's very quick. But the time that is spent is traveling across the ocean. So there is a thing, though, that it's lacking in HTTP 1.1. Now, if I ask for index.html, and then this page contains these resources, then what I can do is create a correlation between the primary resource, the HTML, and the other 3, and say, well, these resources are secondary, and they always go together. When I ask for the index.html, I will need also these other 3. So I can group them together into what is called a push cache, all right? Then I can come in with an HTTP2 browser, and the server has push enabled. And now what I can do is this. I can make the request for index.html, but then the server says, oh, you need index.html, but you're going to need the CSS, the JavaScript, and the image as well, because that's what's needed for you to render the page. And so the server can just push down the HTML, the JavaScript, the CSS, and the image all together, all right? And so this goes into just one round trip. So the rendering in HTTP2 is 3 times faster. That's it. So this is what the web needed. It needed a way to correlate resources together in order for the server and the protocol to be able to say, hey, I know what you need. Here's what you actually need to render this page, all right? And so give back all these resources, shaving off the round trip time, which is the big problem for today's web. It's not about speed of internet connections. Internet connections are really fast, even on mobile. Not a problem. Even if I download 9 megabytes of data, that's not much. What really kills me is going across the ocean, right? So that's super nice, theoretically, but how does it actually work? So let's demo it, and let's see for ourselves how it actually works. So here's the demo. So what I've done here, I have artificially slowed down the localhost interface for this demo to simulate a 200 millisecond delay for the round trip, all right? So the page that is going to come next is a page that is composed of 24 smaller images that compose a larger image. Okay, so only 24. I didn't go as far as going 200 of those, just 24, all right? So if I find my mouse and click here, on HTTP 1.1, this is what happens. Click. Okay, so what happened? You've seen that I clicked, the connection was established, then a few images were coming down very slowly, and then the last images were coming down a little bit faster. So this is actually a feature of the TCP protocol called slow start. So every time you open a connection, you're not really at full speed because the connection needs to be warmed up, all right? And once it's warmed up, well, it's faster. And so if I now reload this page, well, and the browser didn't time out the connection. So if I reload this page, you can see it's slightly faster because the connection is now being warmed up, okay? But still, you see actually all the images coming down and composing the larger image. So this is how HTTP 1.1 works. And if I open the console here and I go to the network tab and I reload this page, this is what you see. This is a typical profile for, let me just scroll this up. So there is a first request for the index.html, and then Chrome, in this case, opened 3 connections to download the first 3 images. But then you see all this gray area here? This is time spent waiting for those 3 connections to actually return the images. So I cannot ask for the next 3 images until the first 3 have come back. And so forth with all the others. It's a stair-like waterfall stuff, okay? This is how HTTP 1.1 works. So let's close this for now. If I can click, what? Where is that? Ah, it's up there, maybe. Close it. Okay, so let's go back and okay. Okay, so let's try now the magic, right? So should expect to be faster, so click. It's immediately faster, okay? We haven't seen those slow start stuff anymore. The reason is that HTTP 2 is much more efficient at using TCP features. And you know, this page already renders faster. But what happened, though? That the server now has a correlation between the primary page and all the images that compose that page. So if I now reload this page, now I get all the resources to be pushed down to the client. And so if I reload this page, and I'm gonna say this like, click, you don't see the refresh anymore, right? It's not like before. You don't see it anymore because it's so fast, and again, click, that it's there, boom, okay? So remember the slide that I gave you before? This is money. It doesn't have the look of money, but this is actually money for your business. Because this fast, people stays on your site. Your business is going to make not 10%, but like a lot more. I was just joking, but you know, this gives you an idea of what does it mean to use a dinosaur protocol versus a modern protocol that has been designed for today's web 2 years ago. This is the difference. Now, if we look at the profile for this, and let me go again to the network tab here and reload the page. All right. So let me just move a little bit around. I'll be off camera, but you know, just to show you. So what happened was this. There you go. So the first request, this is connection establishing, then this is the download data. So the first request came back for index.html, but the server figured out, oh, but you also need 24 images to compose your page, right? So here they are. And so you don't see the other 24 requests because there are no requests. It has already been pushed, everything has been pushed on the first round trip. And so when the browser sees and parses this HTML page, what does it do? It says, okay, I have an HTML page. Oh, look, there's a pointer to an image. I should fetch that image from the server, but before I do that, let me look if it's already in the cache. And then it looks in the cache and said, oh, but the server already pushed this image to me. So it's here already. Let me use it. So I don't make the request anymore because I already have the image in the cache. And same goes for the other 23 other images. And boom, your page is there already. So big improvements. There's no reason to stay on HTTP 1.1 anymore. All right, so let's switch back to the presentation, which has gone back at the beginning, but let's move forward. Okay, so I hope that by now you're convinced that HTTP 2 is the next thing that you have to do Monday. It's not anymore, it's not a technical thing. Well, it is a technical thing, but it's also a business thing, okay? This stuff has a direct correlation with money, with your business. So you don't want to be beaten by your competitors because you stay on a 20-year-old protocol. You want to be on the edge, and the protocol is already 2 years old. Everybody supports it. And so you want to go back to your jobs on Monday and start thinking, how do I deploy HTTP 2 for my own website? And so let's see how. So what is it that is required? Every time you need an HTTP 2 browser to interact with an HTTP 2 server, you need TLS. TLS is SSL, okay? So you need HTTPS on your website. If you don't have that already, well, then it's not good because Google ranking takes that into account. If your website is over TLS, you have a higher Google ranking. So you should really go to TLS. Well, that's a good news because it used to be that you should pay for certificates, right? You should go to a certification authority and pay for a certificate, something like $100, $200 per year. But turns out that now there are certification authorities like Let's Encrypt that gives you certificates for free. So if you have a non-profit organization or even your business company, like our own website, webtide.com, is using Let's Encrypt certificates, and it works like a charm. So the issue of buying certificates, it's a non-issue anymore. It's 2017, things improve. However, the protocol is flexible enough that if you use HTTP 2 on the backend, then you don't really need to be encrypted. If you are within your data center, then you can use HTTP in clear text, HTTP 2 in clear text. However, you must verify that all intermediaries allow HTTP 2. This means, for example, load balancers, okay? You need to make sure that your load balancer is HTTP 2 enabled, or that it does support HTTP 2. So typical configuration for the Java development or deployments are browser, Apache, or Nginx as reverse proxies, and then calling back into Tomcat, Jetty, or Undertow, Wildfly, whatever. This used to be like a standard configuration. It's an old configuration. It's a configuration that is good for HTTP 1.1, but not good for HTTP 2. The reason is that the browser can talk to HTTP 2 to the front end, but Nginx and Apache cannot yet talk HTTP 2 to the backend. They will resort to go back to HTTP 1.1. So let me tell you a war story about this. We have a customer that uses Jetty that had this kind of configuration. Now, the problem is that on this front side, they were getting thousands of requests per second. This means that these guys, in order to fulfill those requests, had to open many concurrent connections to the backend in order to fulfill the 1,000 requests per second on the front end. But if you open these many requests, what was happening? Was happening that the backend server were killed by the TCP overhead of opening those connections and keeping them open and stuff like that. Instead, if this traffic was HTTP2, you would be able to open just one connection and multiplex all the requests into that one single connection. That means a lot less resources. You can buy on Amazon, or you can fire up on Amazon smaller machines, because you don't need all the resources that you were needing before. So that means, again, saving money for your business, all right? Because you need to pay less for Amazon. So typical good configuration is this one that we recommend using HA proxy. But HA proxy is an example. For example, also the F5 load balancer supports this configuration. So what you have here is basically HTTP2 encrypted from the browser to HA proxy performing the TLS offloading, and then talking to Jetty in clear text HTTP2 within the backend. All right. This is a very good solution, because in this case, your application, which is here, it is now able to use HTTP2 push, because the protocol that is talking is HTTP2. Before, it couldn't, because this protocol here was HTTP1, and so even if the application could push data down to the client, the protocol wouldn't allow it. And so, you know, you're stuck with a dinosaur configuration for no reason. So upgrade, this is a good way to go. There are other solutions. My point here is, you know, you have to go back and study what do you have, what is it that you need to upgrade. On the Java world, Jetty 9.4, we have a server and client that supports HTTP2. We run live on webtile.com, but also Tomcat, the HTTP2 implementation for Tomcat has been written for Tomcat 9, but has been backported to Tomcat 8.5. Wildfly 9, Undertow 1.3, Netty 4, OK HTTP is a client only for Android, so you can use it if you write Android application, you can talk HTTP2 with servers. The good thing is that for Java 9, there's not only modules, but also there's a few improvements for HTTP2. In particular, there's a new HTTP client, and this has been moved to the JDK incubator. So it's not really part of JDK 9, but you can find it in the incubator. And there's also support for Server 4.0 will support HTTP2 and a bunch of features. So servlets will have APIs that allow you to programmatically push resources. So for example, you can have logic that does that. Something like, oh, if the customer is a gold customer, then push the data and make his web experience faster. But if it's a guest, well, then we don't bother pushing. Something like that, right? So JDK 8 is required, so upgrade JDK if you're not on 8. And JDK 9 has a support for a very specific feature called ALPN, which is a prerequisite for HTTP2 to work. It's kind of a low-level detail, but it is in JDK 9, so if you're playing with implementing this in Java, it's there. And we have already implemented it. It's live since a couple of months, and so we have tested that this support for ALPN works in JDK 9. We have already implemented it. And so, yeah, this is the new API available that has been added to JDK 9 in order to support ALPN. So, again, Jetty provides a pure HTTP2 client. It's very easy to set up. So this is how you would use the 1.1 client. And this is a one-line change that you need to make in order for the Jetty HTTP client to speak HTTP2. You just change the transport to be the one that uses HTTP2. So all good, right? But this wouldn't be a keynote if I just gave you good news. there are bad news as well on HTTP2. And so what are the bad news about HTTP2? Well, 2 years have passed, and so now we have a little bit more experience of how HTTP2 works in real life. So let's see. This one is a webtile.com website from from Italy to United States and back. It renders in less than 1 second in HTTP 1.1, okay? So you see here the weird gray lines waiting for resources to come back. It's not pretty, okay? Yuck. So let's go to HTTP2 now. It renders in less than 600 milliseconds. It's already 30% faster. And so look at the profile for the resources that have been asked. They all start at the same time. So I ask for the HTML, comes back, parse the HTML, figure out that I need to download maybe a 30-something resources here, boom, send them over to the server, okay? And all together. Then there are some that are really fast and come back very immediately. Some are longer to compute on the server, but that's okay. But if I use Firefox instead of Chrome, well, things don't go that well anymore. So this is due to differences between implementation in the browsers. So Chrome is probably really efficient, Firefox a little bit less. But wait, because that's not the end of the story. Well, there's Edge, of course. So we can all start making jokes about Internet Explorer or Edge browsers for Microsoft. So it's even worse, almost 2 seconds. But there's a big warning here. So we tried Firefox, which was the slow one, from Australia. And Firefox is actually consistently better than Chrome when the latency is higher. So what you see here is a trade-off, an engineering trade-off that the Firefox and Chrome implementers have taken. And someone says, okay, I prefer to be able to cover this use case better than the other one. So measure. Yeah, as I say, big difference between implementations and relatively new protocol. There's a lot more that we need to figure out about HTTP2. Let's skip this. And what is the good thing about HTTP2 is one connection per domain, which is very efficient at the TCP level. We've seen this. Multiplexing the demo was, awesome. But what is the problem if we have packet loss? And that single TCP connection goes down, and you have 20 outstanding requests on that single connection. Now, suddenly, you have failed 20 requests, while in HTTP 1.1, you had 6 connections, maybe 1 experienced packet loss. You still have 5 good requests that will come back, and you just lost 1. Now here, it's a bit worse. So you see, Fastly is a CDN. They have an awesome presentation at this URL where they present the data that they experienced. And so what happens is that when they measured HTTP2 versus HTTP1 in packet loss conditions, then it turns out that HTTP1, this down-user protocol, is still a little bit better than HTTP2. So not very good. So what is the solution? Well, Google, there was the initial proposer for Speedy before and then HTTP2, came up with another protocol called Quick UDP internet connections. Now, they're not using TCP anymore over the internet. Now they're using UDP. And this has a number of benefits because now they have designed this protocol to have 0 round-trip connection establishment. Like, you don't need anymore the 3-way handshake that you have with TCP. It has built-in crypto features, and it can do connection migration. For example, if you have your mobile phone and you're downloading stuff, and you happen to cross a cell boundary where maybe your IP address changes, Well, with Quick, you don't lose a single byte, while with TCP, that would be a broken connection because your IP address changed, and so you have to restart the download. But Quick has been designed to support this connection migration feature. What is the problem with this is that this single protocol now has transport, cryptographic, and application concerns, everything in just one protocol. And there's people like Paul Henning Kamp, which is the guy behind Varnish, the powerful cache, that says, history of protocol design has taught us that we layer protocols on top of each other. We don't mix them together. And so he wrote an email where he was saying, what do you think about Quick? And he said, well, I recoil in horror. So not everybody likes Quick. Plus, it will be very, the effort to implement will be, especially in Java, would be quite large. So let me wrap up this keynote where I really hope that I gave you new ideas to try out on Monday. That was the whole point of the keynote. Conclusion is that web developers typically don't need to do anything. The API that they're using will still work with HTTP2. Application will be able to leverage new features if you want to use them. You don't have to do any more HTTP 1.1 workaround, no domain sharding, no image spriting. All of that is not needed anymore. The deployers, the people that actually care about the data center, they have to be a little bit more aware of what's going on. They need to implement TLS, so you need to have in your company a process that renews the certificates every 3 months or every year. So if you don't have that process in place already, you have to have it, because otherwise your domain expires and it's not good. You have to upgrade your server container, and you have to upgrade your network infrastructure, for example, load balancer and stuff. You have to verify those. So very good news, a modern protocol. Please ditch HTTP1 or think about ditching HTTP 1.1 and go to HTTP2, because thanks.